number 20 shows us something different there with the negative theta things. Maybe theta is not a good thing to call it because I'm going to let theta be something else. But the negative, the arctangent of something negative. All right, that's new. And here's how I'm going to handle that. I'm still going to let the inner part equal theta. And what am I going to do about that negative? Okay, we don't have negative side lengths. I'm going to do this. I'm going to put theta there, all right? And I'm going to call that length negative 3. See what I'm thinking here? Okay? And so then the adjacent would be positive 5. I could have put the negative either place, right? Either on the 3 or on the 5. And it ought to work out. Everything's still going to work out just fine from here. Okay? So if that's the case, then the hypotenuse would be the square root of one leg squared plus the other leg squared. Square one leg, you get 25. Square the other leg, you get positive 9. 25 plus 9 is 34. So that's the square root of 34. Okay? So I'm good now. All right? Everybody with me on drawing the triangle? Either the 3 or the 5 is negative. Doesn't matter. All right, so that's that. Now, we rewrite our original problem. We've decided to let the arctangent of negative 3/5 be theta, so if I rewrote that, all that would be theta. So secant theta is what I'm after. Now, I don't like secant. Nobody likes secant. We all prefer cosine, right? Secant's the same thing as 1 over cosine. So that'll be 1 over, well, what's the cosine of theta? It's adjacent over hypotenuse. So it's 5. It's hard to read that. It's 1 over 5 over the square root of 34. Uh-huh. Yep. Uh-huh. Yeah, and if that happens, we'll live with it. Okay? So it's 20 part A. Seem okay? All right. I'll get you started on part B, and then I'm going to let you finish it. On part B, we have the tangent of the arc sine of negative 5/6. So let's let theta equal the arc sine of negative 5/6. And since sine is opposite over hypotenuse, now here I think it does, I don't know, and maybe I'm just forgetting that there's a reason that I always let it be the vertical distance be the negative one. Maybe there's a reason for that. I don't remember that there is, okay? But it wouldn't make sense, though. I don't want the hypotenuse to be the negative one, do I? Because at least I can make a good argument that even though that distance is 5, it's in the negative direction, so calling it negative 5 makes sense. Calling the hypotenuse negative 6, I don't think I can make an argument for that, okay? So I would stick with that. Finish that problem up. See what you get. No. Everybody get part B? All right, number 26. Now, It's the same idea, but we're going to come up with a different result because look what the directions say. Write the expression in algebraic form. In other words, when we're finished, we're going to have rewritten this expression so that it's just algebra, not trig anymore. Okay? So it's going to be an expression with x's, but not arc sines and secants. All right? So let's start off the same way. We're going to let the part in the parentheses be theta. So let theta equal the arc sine of x minus 1. And then how would we draw that? Let's make a little right triangle. And like we talked about yesterday, if the arc sine of x minus 1 equals theta, that means that the sine of theta equals x minus 1. And in fact, I can put that over 1. All right, so if the sine of theta equals x minus 1 over 1, if I put theta here, sine's opposite over hypotenuse, x minus 1 over 1. Okay? You with me? Now, let's figure out what that missing leg length is. Remember how that works? That leg will be the square root of the hypotenuse squared minus the other leg squared. And I'll show you what I've got now. So that's the square root of 1 minus, and then when you square x minus 1, that'll be x squared minus 2x plus 1. Distribute that negative and get negative x squared plus 2x as the length of that other leg. In just a minute. All right, so we're supposed to write the secant of the arc sine of x minus 1. We've decided to let the arc sine of x minus 1 equal theta, so we're supposed to write the secant of theta. So the secant of theta. And again, we're not huge fans of secant. So that's 1 over cosine theta. So that's 1 over, now the cosine of theta. Cosine's adjacent over hypotenuse. So adjacent is the square root of negative x squared plus 2x over hypotenuse, which is 1. So I've just got 1 over the square root of negative x squared plus 2x. So look what this means. That means that this expression, well, I'll do it that way. That means that the secant of the arc sine of x minus 1 equals 1 over the square root of negative x squared plus 2x. And we have rewritten the expression in algebraic form. There's the original expression. There it is in algebraic form. All right, 26 makes sense? Okay. 32. Solve the equation for x. We have the arctangent of 2x minus 5 equals negative 1. And so far, we've used our inverse trig functions only to help us draw those little right triangles. Okay? But now let's use the fact that inverse trig functions are inverse functions. What would happen if you take the tangent of the inverse tangent? They undo each other. You just get the expression on the inside, don't you? That's what I'm going to do here. Let's take the tangent of the left side and the tangent of the right side. Because there are exceptions to this, but for the most part, you can do anything you want to an equation as long as you do it to both sides. So I took the tangent of both sides. On the left side, the tangent of the arctangent of 2x minus 5 is 2x minus 5. So 2x minus 5 equals the tangent of negative 1. Do not use your calculator quite yet. Let's finish solving this thing for x. The tangent of negative 1 is a number. I don't know what it is, but it's a number, right? All right, so add 5 to both sides. Divide by 2. And we've solved it for x. If the directions tell you you want to round it to a decimal, fine. If they don't, you don't have to. Now, if this was a multiple choice question and all the multiple choices were in decimal, then you would. But now go ahead on your calculator. See if you can get 1.721 like I did. Make sure you're in radian. All right, we good? 47. Find the derivative of the function. Now, let's look and see. We've got an arc sine in there. Look on page 376. Do we have a formula to tell us what the derivative of arc sine is? All right, we do, so we should be in good shape, okay? So on 47 here then, our first rule is the quotient rule. And then within that quotient rule, we'll have to be able to take the derivative of the arc sine of u. So, quotient rule, g prime of x equals all right, g prime of x equals the bottom, x, times the derivative of the top. Now, the top is the arc sine of 3x. So we have to find the derivative of the arc sine of 3x. So I'm looking right at the formula on page 376. The derivative of the arc sine of u equals, now I'm going to write the derivative of u at the end. Just even though I don't always do my work that way, I memorize the formulas better that way. So it's 1 over the square root of 1 minus u squared times the derivative of u. That's the formula. So for this particular problem, that'll be 1 over the square root of 1 minus, well, if we're trying to find the derivative of the arc sine of 3x, u is 3x, isn't it? So 3x in parentheses squared, and then times the derivative of u, which is 3. So it's 3 over the square root of 1 minus 3x quantity squared. That's the bottom times the derivative of the top. Minus the top, arc sine of 3x, times the derivative of the bottom, the derivative of x is 1. All that over the bottom squared. And we have done the calculus. Whatever else we do will be algebra. Okay? All right, you with me? All right. Who likes having the square root of 1 minus 9x squared as a denominator in your numerator? Not me. So I got to multiply by the square root of 1 minus 9x squared over the square root of 1 minus 9x squared. When I do that, I multiply that times that, don't I? That square root of 1 minus 9x squared is in the denominator. That square root of 1 minus 9x squared is a factor in the numerator. They divide out, leaving me with x times 3, which I will call 3x. Next, I have to multiply that square root of 1 minus 9x squared times that. All right? Don't ignore the negative, so either just copy it down or think of it as I'm multiplying a positive times a negative. I'm going to get a negative. Okay? Anything divide out this time when I multiply that times that? Nah. And there's really not a good way to write that either. I'd rather write the arc sine of 3x in front of the radical so I don't think it goes underneath the radical sign. But other than that, you know, it's kind of messy. Everybody with me? In the denominator, what do I get when I multiply x squared times the square root of 1 minus 9x squared? Just get that, don't I? Okay. We're done. What else can you do? I don't see anything else to do. Let me tell you some things not to do. Don't do that. Don't do this. Because it's not arc sine times 3x, is it? It's arc sine of 3x. So don't do that. So we're done. All right. Page 377. 3 through 27 odd, 31, 33, 41 through 48 all.